Have you ever looked up at the night sky and felt a sense of wonder? Those twinkling points of light are not just decorations, they are stars, each with a story to tell. For millennia, humans have gazed at the stars, weaving tales and myths around them. But stars are more than just characters in our stories. They are the building blocks of the universe, and understanding them is key to understanding our place in the cosmos. Tonight, we embark on a journey to explore the fascinating world of stars. From their birth in swirling clouds of gas and dust to their dramatic deaths, we will uncover the secrets of these celestial giants. We will delve into the different types of stars, from the familiar glow of our own sun to the enigmatic allure of black holes. So, adjust your telescopes, space cadets, as we prepare for an unforgettable voyage through the cosmos. Our journey begins in the vast cold expanse of space, where stars are born in regions called nebulae. These cosmic nurseries are immense clouds of gas and dust, the raw materials from which stars are formed. Imagine a giant cosmic cloud, a swirling mass of hydrogen and helium, remnants of the Big Bang itself. Gravity is the driving force behind star formation. Over time, gravity pulls the gas and dust in a nebula closer together, causing the cloud to clump and collapse. As the cloud collapses, the core, the very center of this swirling mass, gets incredibly dense and hot. This intense heat and pressure at the core of a collapsing cloud eventually reach a critical point that triggers a spectacular event: nuclear fusion. Nuclear fusion is the engine that powers a star. It's the process where hydrogen atoms, the simplest and most abundant element in the universe, are forced together under immense pressure and heat, fusing to form helium. This fusion process releases a tremendous amount of energy in the form of light and heat, and this energy is what makes a star shine. The birth of a star is a cosmic ballet of gravity, pressure, and heat, a magnificent spectacle unfolding over millions of years. Stars are not all created equal. They come in a variety of sizes, colors, and temperatures, each with its own unique characteristics. Let's meet some of the stars in our cosmic neighborhood. The most familiar type of star is the main sequence star, like our very own sun. Main sequence stars are in their prime, busily fusing hydrogen into helium in their cores. They come in a range of sizes and colors, from smaller, cooler red dwarfs to larger, hotter blue stars. Red dwarfs are the most common type of star in the Milky Way galaxy. These small, faint stars have incredibly long lifespans, burning their fuel slowly over billions of years. On the other end of the spectrum are the giants, red giants and blue supergiants. Red giants are stars that have exhausted the hydrogen fuel in their cores and have begun to expand and cool. Betelgeuse, a bright red star in the constellation Orion, is a famous example of a red giant. Blue supergiants, on the other hand, are massive hot stars that live fast and die young, burning through their fuel at an incredible rate. Like all things in the universe, stars have a life cycle. They are born, they shine, and eventually they die. But the way a star dies depends on its mass. Smaller stars, like our sun, will eventually run out of hydrogen fuel in their cores. As they start to cool and expand, they shed their outer layers into space, forming beautiful planetary nebulae. The remaining core of the star will shrink down to become a white dwarf, a small dense object about the size of Earth. Massive stars, on the other hand, go out with a bang. When a massive star runs out of fuel, its core collapses under its own gravity, triggering a supernova explosion. This explosion is one of the most powerful events in the universe, outshining entire galaxies for a brief period. The remnants of a supernova explosion can form either a neutron star or a black hole. Neutron stars are incredibly dense objects, so dense that a teaspoon of neutron star material would weigh billions of tons. Black holes are even stranger, regions of space-time where gravity is so strong that nothing, not even light, can escape. And here's the most amazing part. The elements that were created in the cores of stars and scattered into space by supernova explosions are the same elements that make up everything around us, including us. The carbon in our bodies, the oxygen we breathe, the calcium in our bones, they were all forged in the hearts of stars billions of years ago. So the next time you look up at the night sky, remember that you are looking at more than just points of light. You are looking at the history of the universe, at the remnants of stars that lived and died long ago. You are looking at the building blocks of life itself. We are all, in a very real sense, made of stardust.